Okay, so who has, let's see, Daisy, what order did you put them in? Then 2.25, yes. Okay, this is the order they should be in. Any questions over that? We're good? Okay, next page. Is the quotient of two rational numbers always a rational number? Okay, a quotient. Can someone raise their hand and remind me what a quotient is? Very good. That was very good. Quotient means division. Okay, the answer to a division problem. So is the answer when you're dividing something to dividing two rational numbers, is it always rational? Okay, so let's try this. Alex, what is a rational number? Give me a rational number. 0. Okay. Jackson, what's another rational number?
Rational numbers like decimal, yeah.
That's, yes, a decimal can be a rational number.
2.5.
Okay, 0 divided by 2.5 is 0. Is 0 a rational number? Yes, it is. Okay, because I do something once, does it mean it's always going to happen? No. Okay. I may make a basket the first time I do it. It doesn't mean I'm always going to make the basket, right? So we're going to try again to see if it happens again. Okay, Carla, give me a rational number. 1. Abner, give me another rational number. 9. Okay, 1 divided by 9. Equals 0.1 with a line above it. Is 0.1 with a line above it, is that rational? Yes. Decimals that repeat are rational. Okay. Okay, because I do something twice, is it always going to happen? No. Now I can't do every number in the world and check it, right? To find the always. So in order to do that, because we can't use every number in the world, we'd be here forever, you're going to use variables that can represent any number in the world. Okay? So since you can't try every number, okay, since you can't try every rational number in the world, you're going to use variables. So we're going to say A and B are integers. And A cannot equal 0, and B cannot equal 0. A and B can't be 0 because you can't divide by 0. So then we say A divided by B, does that equal a rational number? Yes, it is. Okay. A rational number is two integers divided by themselves, right? Okay. And that's what a rational number is. So this is rational. Okay. This also means that rational numbers are closed under the operations of division. Okay. That means the closure property means if I have two rational numbers, exactly what this is, and I use the operation of division, then it's going to give me another rational number. Okay. So the quotient of two rational numbers is rational. Is always rational, I should say. Okay, so that is our answer. Yes, that's true. And then this is our explanation. Okay, all that work is the explanation. And then that's our answer. The quotient of two rational numbers is always rational. Any questions over that? Okay, next one. Now they're asking, is the difference of a rational number and an irrational number always irrational? Okay, so let's review. What does a difference mean? Anyone raise their hand and tell me what difference is? Subtraction. Okay, difference means you're subtracting. Okay, so we're subtracting a rational number. So again, I need a rational number. Joel, what's a rational number? Okay. Then we need an irrational number. Can someone give me an irrational number? Pi. So we're subtracting pi. 1 minus pi. We're going to use our calculator. Most of your calculators will have a pi button, so use the pi button. And that gives me negative 2.141592654 ... Okay, so on my calculator, it ends at 4 simply because it runs out of room. It continues on forever. So you need to have that ... Okay, so is this number rational or irrational? Irrational. But let's think logically. If you have a number that decimal ends and I subtract a number that the decimal never ends, will my answer ever have an ending decimal? No. Okay? The decimal is going to go on forever. It might get a smaller decimal, but it's still going to go on forever. Okay? So what's always going to be an irrational number? If I subtract a rational and an irrational, it'll always be irrational. Okay, I'm going to prove that to you and watch a wonderful video and take some notes on it. Okay? On the same place, yeah. And I'll write it on. So you'll see.
Is the sum of a rational number and an irrational number a rational or irrational number? An integer divided by a non-integer. So for A
Hold
divided
on.
by B and P divided irrational number. Write the sum of an irrational number and a rational number as a rational number. Every rational number can be written as an integer divided by a non-zero integer. So for A divided by B and P divided by Q to be rational, A, B, P, and Q are integers with B and Q not equal to 0. Solve the equation for C.
Okay, so we're gonna go back to our notes and write that down. Okay. So it's A over B plus C. Although they're showing to you in regards to sum, it would be the same thing with subtraction. They just have the negative sign there instead of the plus sign. And it's gonna equal P over Q. Okay. A over B represents a rational number. C is representing an irrational number. And they're saying it's going to equal a rational number. They've also said that B and Q, oopsie, that's a G. Sorry, let's write this better. That B cannot equal 0, nor can Q, because you're dividing by P and or B and Q, and you can't divide by 0. They're also saying that A, B, P, and Q are integers. And C again is irrational. They then are going to ask you to solve this. So they want you to get that C by itself. So how do I get C by itself? How do I get rid of A over B? Very good, subtract A over B. So that's gonna give me C is equal to P over Q minus A over B. Now, when we subtract fractions or add fractions, we need a common denominator. Okay, so we need our denominator to be B over Q, or B times Q. So to get B times Q, I need to multiply this denominator by B. If I multiply the denominator, I also need to multiply the top. So that's gonna give me PB minus A and B. I need to also make the denominator BQ. So I need to multiply the B by Q here. A times Q is AQ. Sorry, that's very hard to read. Okay, so now let's review. Once I do this, this still is irrational. Here I had two fractions that were rational. When I added them, if I add two things that are rational, do they stay rational? Yes, right? 5 plus 7 is 12. That's a rational number, okay? So this is still rational. Can an irrational number equal a rational number? can I be both rational and irrational at the same time? Not at the same time. In a second, I can change from rational to irrational. But at the same moment, I can't be both rational and irrational. Does that make sense? Okay. So that's same true with numbers. An irrational number cannot equal a rational number. They're opposites of each other, kind of. Okay. So an irrational number cannot equal a rational number. Okay. So the sum or the difference of a rational number and a irrational number is always irrational. Any questions over that? Okay, I want you guys to answer this question. When is the square root of a number irrational? And give an example. So in your pairs, come up with when that is. Okay, Kenneth, when is the square root of a number irrational? Okay, so when the decimal, okay, that's true, that's an irrational number, is a never-ending decimal and it doesn't repeat. Anyone else have a good way to know when that's going to occur? So when will that occur? When will a square root continue on forever? Jacob. Okay, can you give me an example of a square root that is irrational? Square root of 0? Square root of 0 is 0. Square root of 4 is, what's the square root of 4? 2. Is that an irrational number? No. 9. What's the square root of 9? 3. Is that an irrational number? We want it when it's going to be irrational. You're doing all kinds of rational numbers. Yes. Not just odd numbers, because 9, what's the square root of 9? 3. And that's a rational number, not irrational. But that's on along the line. Not just prime numbers. Well, prime numbers are going to be that, but it's not just, well, no, yeah, no, it's not just prime numbers. Yeah. Pi, but that's just square root of an irrational number. But the square root of 7, okay? That's an irrational number. If you plug that into your calculator, you get a decimal that goes on forever. Okay. So what is it called when I have like the square root of 4? That's a rational number. And we call that a perfect square. Okay? So square roots that are going to be irrational is when the number is not a perfect square. Okay, we call it a perfect square because the side lengths, it's the area. The side lengths of a square are going to be the same. Okay, so the square root of the number has to have the exact whole number that are the same. Does that make sense? Okay, so there's lots of numbers that are not perfect squares. Square root of 7, we did square root of 23, square root of 2. Okay, whatever one you put down. Okay, on the next page, I want us to go down to this. This goes in line with it. Okay, it's the bottom of that check for understanding. It has a little square that's blue. Okay, the park shown is in the shape of a square. Is its perimeter rational or irrational? So let's start by what is a square? 4 equal sides. 4 congruent sides. So this side is going to be the same as this side. It's going to be the same as this side. It's going to be the same as this side. Does anyone remember area of a square? Length times width. Area is equal to length times width. In a square, the length and the width are the same because all the sides are equal. So if I use my area formula, the area they gave me was 24,200. And then the length and width are both x, so x times x. So my equation becomes 24,200 equals x times x is x squared. Hey, do you guys remember how to get rid of a square? Square root, right? The inverse of squaring something is square rooting it. So I'd have to square root both sides. So that gives me x equals, let's see, is 24,200 a perfect square? No. It's 155.56, and it goes on forever, right? As a dot, dot, dot. So is this an rational number or an irrational number? Irrational, good. Okay, now we also need to review what perimeter is. What's perimeter? Adding up all the sides. Okay, so if I add a bunch of irrational numbers, is my answer going to be irrational or rational? Irrational. If I add irrational numbers together, they're going to be irrational. If I add rational numbers together, the answer will be rational. Does that make sense? I will never add a bunch of rational numbers and it becomes irrational. I will never add a bunch of irrational numbers and my answer will be rational. Does that make sense? Okay. So the perimeter will be irrational because when you add irrational numbers, they equal an irrational number. Okay.